So last week we talked about the role that control groups play in establishing internal validity of studies. And if you remember, what we meant by internal validity is the ability of a study to inform the question that we're asking. And we focused on questions of effectiveness. So if we want to know if cognitive behavioral therapy is an effective treatment for depression, what we need is a study that can help us determine whether doing cognitive behavioral therapy versus doing usual care will lower rates of depression. In order to do that, we have to establish or find a good control group. The reason we need a control group is because there are other things happening in the world, whether it's events or personal changes like growing or maturation. Sometimes people come to see us when they're at their worst and they regress back to the mean, and so their improvement is just the natural course of things. And in order to distinguish between those threats to internal validity and the effectiveness of something like cognitive behavioral therapy in reducing depression, we need to find a good control group. And we identified randomly separating a single group of people into the treatment and the control group as the most effective means we have available for establishing good internal validity of a study through the use of randomized controlled treatment groups. Often we refer to this as a randomized controlled trial. Sometimes we can't do randomness, and we have to rely on quasi-experimental methods, something like a wait group, a waitlist group, or some other mechanism to find a control group that looks as close to as possible the treatment group. And so these quasi-experimental methods are not as good as randomization, but often they're good enough. And this week, we're going to talk about another topic that is going to have a very similar message. This week, we're talking about sampling, how you get the population that you're going to, or the sample of the population that you're going to study. And you can immediately see the connections between what we talked about last week and this week. So last week, we talked about the creation of these two groups. This week, we're talking about how you find the people to populate those groups with. And the same kinds of questions are going to come up. Whereas last week we were focused on the internal validity questions, this week we're going to be more focused on the external validity questions. And surprisingly, or not surprisingly as the case may be, the answer to our problem is going to be randomness again. Randomly selecting from among a population to create a sample is the most effective method we have for creating high quality samples. But often we can't randomly select people from a population to fit in our sample. Sometimes we have to go with convenience. Sometimes it's too hard to find people, so we have to use people that we've already sampled. There's a variety of different non-probability based sampling techniques that we use to substitute for random sampling when we can't do that. So last week we talked about random assignment to a treatment group and a control group. This week we're going to talk about random selection from a population into a sample. There are different ways that we're using randomization, but in both cases, randomization solves a problem we have of selection bias. We don't want to have selection bias between the treatment and control groups. We don't want to have a treatment group that is very sick and a control group that's really healthy. That's going to induce, you're comparing apples and oranges. Likewise, if we want to make a statement about a population, we want to get a representative sample of that population. Randomness is the best mechanism to do that. We might have to use alternative approaches. So in both cases, randomness is the solution to our problem. Those terms often get confused, random assignment from last week and random selection from this week. They're different but related concepts. Sampling is the selection of a group of people or objects or whatever our unit of analysis is, whatever the thing we're studying. We might be studying clinics. We might be studying pets. We might be studying people. We most often study people. But whatever it is that we're studying, we're going to take a sample of that from a larger group, a population. So we are interested in people with depression. That's the population. We're going to take individuals from that group of depressed people, and how we take those individuals is the process called sampling. We're going to then use our sample to make inferences about the population. So we have a population. We're going to take a representative group, or as close to a representative group as we can possibly get. And then we're going to make statements about that sample and make inferences about the larger population. And that's, in large part, the whole process of research described from a sampling frame. So why do we sample? Why is sampling necessary? Well, as I've mentioned before, we want to have external validity. We want to be able to make statements about a larger group of people by investigating a smaller group of people. We usually can't talk to everyone that has some condition. We can't talk to all depressed people. We can't look at all Medicaid clients. So we need to take a smaller group to have them stand in for the larger group. And the degree to which our study is able to do that is external validity. A lot of the procedures we're going to talk about are mechanisms for getting unbiased samples. What I mean by an unbiased sample is a sample that is representative of the population at large. So if you think about the problems, so one of the most common ways in which you encounter, if you're somebody that likes politics, encounter sampling is through polls. So what polls do is they call a small group of people, generally about 1,000 individuals, and they use those 1,000 individuals to represent everyone in a state or everyone across the country and try and get a sense of what the political pulse is that's going on in the country of 365 million people by just taking a small group of 1 million people. Unfortunately, for the samplers, for the pollsters, is that they're really reliant on telephones, landline telephones, because for a variety of regulatory reasons, those are the best ways to get in contact with people. But like you, I just have a cell phone. I don't actually own a landline. And many people my age and younger are in that same situation. So when you rely on telephone calls to landlines in order to find out what's going on, you end up with a biased sample where you get a lot of people that are my parents' age, in their 60s, 70s, and 80s, who still have landlines. And so in sampling for political opinions, folks that do this work have to be very concerned about getting as representative and unbiased a sample as possible, because if they just do random digit dialing, if they just randomly call a phone number, which is traditionally how they did it, what you end up with is an older sample and typically a more female sample, because older females tend to be at home more than older males. So, and older females live longer than older males. So, so there's a bias to the sampling if you do random digit dialing. And the pollsters have to work very hard not to get a random or biased, not to get a biased random sample. The degree to which somebody sampling from a population is able to get a representative sample, they can then make generalized statements back to the population. So if I get a sample that looks very similar in the conditions that I'm interested in to the population at large, when I conduct my analysis of the data I collect from that small group of people, I can then use that to make statements about much larger groups of people. And that's called generalizability. So the extent to which my study is able to generalize from my sample to my population is exactly what we're trying to accomplish in sampling. And I've used the term external validity to talk about this. I've used the term generalizability to talk about this. They're basically interchangeable terms. But in doing your projects, when you are looking at an article and evaluating the sample, you really want to be thinking about what is the population they're speaking of. Are they speaking of foster children? Are they speaking of homeless people? Are they speaking to the population of people with depression? And if they want to make statements about those groups, does their sample accurately represent those groups? So for example, if I want to talk about people in the population that have mental health problems, but I go to a mental health clinic to find out about people with mental health problems because I know they're there, they're at the clinic because they have a mental health problem and they're convenient to sample. The problem is that in the population at large, a lot of people with mental health problems don't go to clinics. They're not interested in receiving mental health services, or they don't know that they have a mental health problem that can get services, or they don't have insurance to get services, or a variety of different ways in which people that have need don't get access to services. So by sampling just from clinics, I have a biased sample relative to the population that I'm interested in. If I am interested in, among people that come to my clinic, why don't people come back? why do people come to one visit and then not go to a second visit? I can sample from among the clinic because I'm actually interested in the population of people at the clinic. And so the population that I'm drawing the sample from is the same as the population that I'm interested in. And so the degree to which the population of interest and the sample are matched, that's a good study. That's going to have good external validity, good generalizability. The degree to which there are differences between who I'm sampling and the population I want to talk about is going to create bias in my ability to make generalized statements from the sample to the population.